Hello, everyone, and thank you for joining us today. We're excited to present our project, Evaluating Tree Coverage at DC Bus Stops through Python. I'm John Lesko, and joining me are Eden Rotunda and Nils Berglund. Our project focuses on improving urban heat resilience in Washington, D.C. by identifying bus stops that are most in need of tree coverage. Let's dive in. In Washington, D.C., many bus stops lack shade from trees. This forces people to wait in direct sunlight, which isn't just uncomfortable, it can be harmful to their health. With rising urban temperatures, this issue is becoming more and more urgent. Tree coverage can reduce heat exposure, and research shows that it plays a significant role in making cities more livable. This is especially important in communities where public transit use is high and resources to mitigate heat impacts are limited. Our project addresses this by identifying the bus stops most in need of tree coverage.
Our solution was to develop a multi-criteria evaluation, or an MCE model, to determine which bus stops are the highest priority for tree coverage. We considered 5 key factors: bus ridership, levels of poverty, minority population, elderly population, and local temperature change. We then calculated a tree need score for each bus stop. Higher scores indicate a higher need for trees. We are then able to determine which bus stops should be prioritized when determining where to plant trees in the future. For this MCE, our analysis is done completely through Python. Our process began by utilizing spatial functions that map bus stops and create a 30-foot buffer zone around each one. These buffers will then serve as our study areas for analyzing tree coverage. Next, we standardized each dataset and assigned weights to the 5 factors based on their impact. This is done by calculating the z-score for each relevant field, or how far they stray from the mean, and then determining how much they should weigh in on the final MCE value. For example, bus ridership and temperature were weighted most heavily at 33% each.
Going further into the code, after we had calculated the z-scores of every data point for all of the 5 factors, we reclassified them into a standard scale using the code block on the right of the screen, with the negative scores being lowest and positive scores being highest. Then we computed the final MCE score using the weighted formula shown in bold. Each factor's weight was decided by us based on our determined level of importance for each factor. Here are the results of our analysis. We identified the top 10 bus stops in Washington, D.C. with the highest tree need scores. These stops represent the areas where tree planting would have the most significant impact on reducing heat exposure and improving public health. R script also produced a feature class noting each tree-less bus stop's MCE score that can be downloaded and taken into ArcGIS for further spatial analysis. This data is now ready for use by city planners and environmental organizations.
We'd like to acknowledge our data sources and supporting research for this project. These include data sets from Metro, the USGS, the DC Open Data Portal, and the US Census Bureau, as well as research on urban heat islands and public transportation. This project is a testament to the power of data-driven decision-making in tackling climate challenges.
Thank you so much for watching our presentation. Please feel free to let us know if you have any questions about our project, our processes, or any feedback that you might have for us. Thank you.